In this recording, we're going to look at another type of shape that we can graph with polar equations called a polar rose. And rather than tell you about them, I'd like you to explore them a little bit. So we're going to start out by going into a browser. So if you would get a browser open, and what you're going to Google up is Desmos Rose Curve Exploration. And choose the first hit that comes up. And you should see something that looks like this. Let me make the window just slightly smaller so you can see the settings. There we go. So over on the right side, I would like you to click on Graph Settings and change that little wrench there. Change it to degrees, please. Everything else should be alright. So we're in degrees, and we have a rose curve here. And the equation in generic form is a cosine n theta. It could also be a sine n theta that comes up down here. So what you're going to play with a little bit is the value of a. Play that, bigger, smaller, see what that does to impact the curve. And then play with n a little bit. And when you've finished playing around and kind of observed some things, let's come back over here to our table, and I'd like you to make an observation about the effect of changing a, and then complete the table for n equals, let's go from 2 up to 10. And then just fill in the number of petals that occur with those different values of n. Okay, play the recording when you're ready. Okay, so one thing we observed was that when we increase a, in other words, the absolute value of a, it's the radius of the petal. Gives us longer petals. And increasing n affects the value of the number of petals, but not in a uniform way, right? So 2 produced 4 petals, whereas 3 produced 3 petals, and so on. So hopefully you picked up on that and filled in this table. So 4, 5. And you notice something here, that when we had 4 as n, we actually got 8 petals. And 5 produced 5 petals. But 6 produced 12 petals, and 7 produced 7. And 8 produced 16, and so on. Okay, so the number of petals depends on whether n is even or odd. So if n is even, we have 2n petals. If n is odd, we have just n petals. Okay, and I guess I could do the absolute value here because we don't have negative petals. I'm just going to go ahead and put an absolute value in here. Probably a little more precise. Cool. So let's actually graph one of these specifically. On your graph paper, if you have access to a graphing calculator, that will be handy. If you don't, well, I'll give you the points from my graphing calculator so you can graph this particular polar rose. You should anticipate right now, based on what you saw, what the radius will be and what the number of petals will be. So already have an idea of what you might think it will be. You could even graph it in Desmos if you like. Okay, we have an option down here to graph sine of theta. You can click on the green and undo that and click down here, and it'll make a red one with those particular values of a and n. But now it's the sine of the function rather than the cosine. So you might play with that and just say, okay, what's the effect of having a cosine versus a sine? What's maybe smaller values of n would be handier, but just what do you notice in there? If it's sine versus if it's cosine, etc. So just play with it a little bit, make some observations. And when you're ready, come back here and we will make a graph. Okay, so hopefully you're back, and we're just going to pop that function into our graphing calculator. We'll go in here, clear out whatever's there, and we're going to do 5 times the sine of 2 theta. Okay, we're going to set up our window. That should be fine. Maybe even could bring it in a little bit, but that's fine. Alright, and it's not squared up. We could hit zoom, square, choice 5, square up our viewing window. And that's what we expected. That's what we saw in Desmos, right? If you had actually done it in Desmos. 4 petals, n is even, double the number of, or the petals is double the number of n, and a radius of 5. Okay, so it extends out 5 in all directions. So cool. So where would we be able to get the points for this? Well, let's check out our table. So we'll go second table set. Let's start at 0. Let's increment by tens. And then we're just going to shoot over to our table. We're going to start plotting up these points on our polar graph paper. So I will copy these into the notes so you can see them, and then I'll give you an opportunity just to plot those points. So carefully plot all those points, and we'll see the polar rows. Okay, so now we're going to take all those points and make a polar rose. Because we know the radius is 5 and we've got radius 10 graph paper, let's go ahead and go every other radii, every other ring. So we'll go 0, 1, 2, 3, 4, 5 will be the outer ring. Here are the points that I'd like you to plot, or if you have your own graphing calculator, go ahead and put in the function 5 sine 2 theta. If you don't have your own graphing calculator, just pause on this screen, plot all those points, then play the recording when you're ready. Okay, so hopefully you did so. You got those points plotted, and I'm going to go ahead and make the graph. Okay, so now when I've got one petal drawn. On the angle of 100 degrees, I have a radius of negative 1.71, right here. So what's that going to look like? I'm going to reflect through the pole to the other side of the pole there. So all these negatives are really going to come out the other side. They're going to be down here in the 4th quadrant. So I'm going to go at 100 degrees. I'm going to come out 1.71. So I'm going to look something like that on 280. Right, there it is. So now I'm plotting the point 190, 1.7. Okay, this is coming along nicely. Now we just need to graph the final set of points. We are now up to 270, 0, and again 280 introduces a negative radius. So we're going to go across the pole. At 280 degrees, we're going to come across the pole to where 100 degrees would be and plot 1.71. So it kind of lines up with that other point there on 80 degrees, so that gives me some confidence that I'm in the right place. Okay, a little rough around the edges, but there's our polar rose, and I don't think it looks horrible. Hopefully yours looks even better. Thanks for watching.